All right, let's jump right in. Welcome to today's explainer. Today, we're looking at coding, but we're going to treat it like a literal physical construction project. Think about it. If you were tasked with building a massive, towering skyscraper, you wouldn't just walk onto an empty dirt lot, start chucking bricks around, and just hope a functional building somehow appears, right? No way. You need solid engineering, you need a master plan, and most importantly, you need an unshakable foundation. Today, we're taking that exact same architectural mindset and applying it directly to object-oriented programming. We're going to focus specifically on constructing the basic blueprint of a Python class, really bridging that gap between high-level architectural concepts and the actual step-by-step code you need to build them. So here's our game plan for the build today. First, architectural foundations, then defining the blueprint. After that, step-by-step class structure, and finally, the final build.
Let's kick things off with Section 1, Architectural Foundations.
So what exactly is an architectural foundation? Well, it's the underlying logic, organization, and structural blueprint required to build robust Python code. We're taking that physical building metaphor and linking it straight to your software architecture. Look, robust code doesn't just happen by accident. In Python, if you don't intentionally design your foundation, your data and your behavior are going to end up completely disjointed. But by taking the time to design an underlying blueprint, you naturally adhere to some absolutely crucial programming principles, like modularity and DRY, which stands for Don't Repeat Yourself. This specific level of organization guarantees your code won't become fragile and just completely collapse under its own weight as your application scales up.
Moving right along to Section 2, Defining the Blueprint.
You know, every single developer faces this exact crossroads at some point. On one side, you've got unstructured code chaos. And hey, we've all been there. This kind of chaos usually happens because developers rely way too much on disconnected global variables and just endless procedural functions. It literally leads to spaghetti code, endless scrolling just trying to figure out where a specific piece of data lives, and the absolute nightmare of trying to fix a bug in a system that has zero central organization. But then, on the other side, we have architectural foundations. This represents object-oriented programming, which neatly encapsulates those disconnected variables and functions together into a single logical entity. It basically brings order to the chaos and makes debugging incredibly efficient. So how do we actually cross over from that chaos into order? It all comes down to a class in Python. That exact, concise phrase, straight from our source material, is the ultimate organizational blueprint. In technical terms, a class is a user-defined prototype that acts as a really strict template for creating objects. Instead of having pieces of data just floating around randomly, totally separate from the functions that modify them, a class binds specific data, which we call attributes, and specific actions, which we call methods, together into one cohesive, modular structure. It's truly the fundamental tool that makes object-oriented programming even possible.
Okay, let's get our hands dirty. Section 3, Step-by-Step Class Structure.
Let's translate this whole conceptual blueprint into actual Python syntax with a step-by-step tutorial breakdown. Step 1. Establish the architectural foundation. In code, this literally starts with using the lowercase class keyword to name your structure. So, for example, typing out class skyscraper to initialize your new template. Okay, step 2, define the blueprint. This is where you use the special __init __ constructor method alongside the self parameter. I know it sounds a little complex, but this combo just allows you to define the blueprint's core attributes right when it gets built, like setting the specific height or the number of floors for your building. And finally, step 3, construct the class in Python. Once the blueprint and its attributes are clearly defined, you actually build the physical structure by instantiating the class. You just assign it to a variable, officially transforming your written template into a usable, active object running dynamically, right there in your code. Let's just take a quick breather to review the exact structural components we just erected. To successfully scale your projects, you absolutely must do these 3 things. First, establish solid architectural foundations using that core class declaration. Second, utilize the blueprint metaphor by explicitly setting up your attributes with the __init constructor method. And ultimately, organize your code by actually instantiating that class in Python into working objects. Mastering these 3 technical pillars is exactly how you write consistently modular, reusable code every single time. Which brings us to our last section, the final build. The ultimate foundation is a class in Python. Seriously, if you remember absolutely nothing else from our explainer today, lock this crucial takeaway into your mind. Mastering the class structure and really utilizing those attributes and methods is exactly what shifts you from simply writing messy procedural scripts to legitimately engineering scalable software architecture.
You've got the master plan now. You understand how to draft specific attributes and methods with a clear architectural mindset, totally eliminating that unstructured chaos in your development environments. So now that your architectural foundation is built, the only thing left to ask is, what will you construct in Python next? That empty lot is all yours. Go build something amazing.